All right, so we are recording now. I like this gallery view. That's a lot better than that seat view. So we've got how many people here? 21. So that's pretty good. All right. So we're going to talk about numerically summarizing data. And so, all right, the mean. The mean is what we've commonly thought of as average. Okay. So basically, you just add them up and divide by the sum. The median is what we were going to refer to as the middle value. If it's odd, you'll pick n plus 1 divided by 2, and I'll explain that in just a minute. If it's even, we're going to just find the two middle values. The mode is the most common value. So let me ask, so these are three different ways to think of the quote-unquote average, okay? So geography majors at the University of North Carolina make an average salary of $620,000 per year. Find the mean, the median, and the mode, okay? So the mean is basically, okay, so we've got 5 geography majors here. So major number 1 makes 20, by the way, well, here, we'll finish this. Major number 1 makes $20,000 a year. Major number 2 also makes $20,000 a year. Major number 3 makes $25,000 a year. Student number 4 makes $35,000 a year. And student number 5 is a very famous person that makes $3 million per year. Does anybody know who this person is from the University of North Carolina?
Michael Jordan.
Michael Jordan, very, very well done. Okay. So did you know that Michael Jordan, actually, two interesting things. Number 1, did you know that he was a geography major? Probably didn't know that. Number 2, who watched what's it called? The Last Dance this summer? Michael Jordan. Okay. McKay and Christian did. Okay, so this question is for McKay or Christian. Did you remember what Michael Jordan's major was before he was a geography major? Oh, how could you not? Oh my goodness, how did you not remember that? He was a math major, believe it or not. Do you know that? He switched to geography because he couldn't keep up with his classes because, you know, it's hard to be a college athlete and a math major. So anyway, he switched to geography. So at any rate, okay, so if you add up all these numbers, if you divide by 5, that comes out to a mean salary of $620,000 per year. So based on these 5 students here, do you think 620,000 is an accurate representation? So I'm going to do the poll question here, accurate or not accurate? Give me a thumbs up on accurate or not accurate on that $620,000. Okay. All right, so it looks like it's unanimously not accurate. Why? Why is it not accurate?
Because you have one huge outlier that's skewing the results.
That's right. We're going to talk. Yeah, Michael Jordan clearly is an outlier here. Okay. All right. So one of the problems with the quote unquote mean, and by the way, I'm going to refer to the average as the A word now, is it is highly influenced by outliers. Now let's talk about the median, okay? So the median, so I've got 5 people here, and these are sorted, which is really nice. So you do need your data sorted if you're going to find the median. So I've got 5. So 5 plus 1 is 6. 6 divided by 2 is 3. So all I do is I count 1, 2, 3, and this becomes the median salary, 25,000. So the question is, which one? Well, maybe I'll do that first. So the median salary is 25,000. So based on these salaries, median probably seems like a more representative value. Now the mode is the most common value. So what is the most common value out of these 5 salaries here?
20,000.
20,000. Okay. So here is the next poll question. Which is most representative of geography major salaries? So we'll vote on this. The mean, and I'll just remind you that's $620,000. Median, which is $25,000. Or the mode, which is $20,000. What do you guys think? Okay. Looks like we are unanimous again. 15 votes in out of 20, so that's pretty good. All right, so yeah, I'd probably go with that as well. So the nice thing about the median, it is less subject to outliers, or less influenced, maybe I should say it that way. Less influenced by outliers. Now, my question here is, what if, I'm going to change this salary here from 35 to 25. What would be the mean in this, or excuse me, what would be the mode in this case?
I would say $22,500, the average of the 2 modes, maybe.
That's a good guess. But yeah, we're not going to average those. So we would actually have two modes. Yeah, you'd have 2 modes in this case. So it would be 20,000 and it would be 25,000. So now let me ask you this question. What if this was, here I'm going to change this to 22,000. What would be the mode now?
You wouldn't have one?
Yes. So you'd have no mode. Okay. So you can have no mode, you can have 1 mode, you can have more than 1 mode. Okay. All right, now, next question here. I don't know if I can insert a number 6 because this is a table. Here, we'll put this back the way it was. So 20,000, 20, yeah, that's how my original data set was. Let's say that I had, oh, this isn't going to work. I'm going to add a number 6 salary, which is going to be $40,000. Okay. Now, if I've got so at this point, I've got an even number of my sample size is an even number. I've got 6. So 6 plus 1 is 7. 7 divided by 2 is 3.5. Well, I can't count to 3.5. Okay. But what I will do is kind of what we did with the mode earlier. I will take the mean of those 2 values there. So if I have 6 students here, and really, so these are the 2 middle values here. So what would be the median value in this case?
30,000?
30,000, that would be correct. Okay. All right. So, oh, I guess 30.1 was pretty short. Okay. So yeah, so this is basically the mean, median, and mode. Median, it depends on whether you have an odd or an even number. If it's odd, you're just going to take the middle number. If it's even, then you'll take the mean of the 2 middle numbers. Okay. I a lot of times have a, yeah, we're going to do this. Okay. I do a class activity, but I'm not going to do that since we're all here, and it's hard to break up into groups. So, all right, well, 3.1 was pretty easy, huh? Find the mean, median, and mode. That's not too bad. We are going to move on to 3.2. Okay, so here's what I'm going to do with this. 3.2, this will be the first time we actually get into some slightly harder stuff, okay? Let's say that we have 2 farms. So we have an Idaho farm and we have a Las Vegas farm. And we're trying to buy potatoes. And so I buy 2 potatoes from the Idaho farm. 1 potato weighs 4 ounces, 1 weighs 6 ounces. And in Las Vegas, I buy 2 potatoes. 1 weighs 1 ounce, 1 weighs 9 ounces. And so in both cases, I think we can figure out that the mean would be 5 ounces for both farms. Okay. So is it true that it doesn't matter which farm you buy it at because the potatoes are the same? So what do you guys think? Yeah, potatoes aren't the same, right? Where would you, so here we're going to do another poll question. If you were buying potatoes, where would you like to buy them from Idaho based on this data or Las Vegas? Idaho got to stay local. Are you in Idaho, Alexander? Because Las Vegas is local if you're in St. George. Okay. All right. Usually I have a couple of gamblers in here. That's why I picked Las Vegas as the other one. You know, some people are like, nah, man, I want to get the jackpot. I'm gonna get this 9-ounce potatoes here. Okay. So as we can see here, the Idaho farms are a bit more consistent, right? Las Vegas, it's boom or bust. Okay. Just like the city. So we can talk about range, okay? So range basically is the maximum minus the minimum. I would ask you on the test, I know the book doesn't do this, but so we've got a range of 2 ounces here, we've got a range of 8 ounces here. I would prefer that you would say it's 2 ounces and it's from 4 to 6. And 8 ounces, it's from 1 to 9. And so I would ask, when you do this on the test, we're going to find out who was paying attention in class. I would like you to put the endpoints when you're doing the range, as well as just, I think the book only says 2 and 8 in this example, but I would like you to put the endpoints in there as well. Now, the interesting thing is, was there a question?
Yeah, I was just going to say real fast. I mean, does it matter if we start with a lower number? Because, like, just me with the mathematical, like, I would almost want to put, like, 9 minus 1. I mean, does that matter to you, just as long as we put it?
I don't really care that too much.
Okay.
So, all right. So range is a measure of dispersion. But if I put in let's add a third potato to each farm, 5 and 5, you can see that my range doesn't really change. I've actually made it a little bit more consistent in both places, okay? But so, because the range is kind of a quick and dirty measure of dispersion and way too easy for this class, right? So we got to do something harder, okay? So all right, so I'm going to introduce to you a couple of formulas. We've got the population variance, which is the sum of x sub I. X sub I is going to represent each data point minus mu over squared. So it's the sum of the data minus the mean, this quantity squared. And then this weird looking symbol, it looks kind of like an E, is the Greek letter sigma, okay? Anytime you, well, so this is interesting. So we've got this weird looking, it kind of looks like an E thing, but that's the Greek letter sigma. This circle with the tail on the top is also the letter sigma. Those are actually the same letter. That's the capital sigma, and this is a lowercase sigma. So actually, I need to relabel this. This is not sigma squared. This is S. So these are the formulas here. Now, there's actually a couple of different formulas. These are the two formulas I'm going to give you. Actually, well, I will remind you this on the test. Here, I'm going to copy this. I'm going to put it over here. Okay, population variance is that formula there. And your sample variance is this formula here, okay? Now, you don't have to memorize these because, let me just remind everybody here, this is when the formula sheets are going to start to matter. So if you, here, I will show you the book. Let me show it. I'll go back to my screen. Now, I know I'm a small screen, but so in your book, you've got this thing that folds out like this, okay? It's in your book. Anyway, it folds out. I've also put that exact same thing in your announcements. So if you go here to statistics class, if you go to announcements, I think I mentioned this on the first day of class, but we've got the book tables here, okay? And it's a PDF file. So this is something that you can print out for tests and quizzes. I will guarantee you on the test, I usually don't give you test questions, but we've got, so these are going to be all of the formulas that we're going to use for the entire semester. We're going to go up through at least chapter 14, I believe. And we've also got these tables here. So you got your random number table. We've got the standard normal table and t-distribution, all this stuff. So we're going to use all of these tables and everything. So feel free to print out a copy of this. It'll have all of the formulas that you will need in this class. So for example, we've got the population standard deviation right here. They've got two versions of the formula. I actually think that one's a little bit harder to use. We'll try to use it though. But here's your sample standard deviation. So remember in chapter 1 where we had to distinguish whether we were using a population or a sample, okay? It's going to be important to remember because if we're using a population, we're going to use this formula. And if we're using a sample, we're going to use this formula. And in fact, yes, okay. So I've got those two formulas here. So let's pretend that I have a farm and I've got 5 potatoes, 1, 2, 3, 4, 5 ounces, okay? I buy 5 potatoes and they're all here. So, so let's talk about standard deviation, okay? And think of this as the average distance from the mean, okay? And so what I'd like to do is I'd like to do kind of a conceptual idea here. So let's say here, let's pick on, who are we going to pick on? We'll start with Marin, I guess. Marin, as you look at this data set here, if I can get back here, without thinking too hard, could you tell me what you think the mean is of those 5 values right there?
3.
3, very good, okay. So we've got a mean of 3, okay. So let's go with Zach. Zach, what's the distance between 1 and 3?
Wouldn't that just be 2?
Okay, how about 2 and 3?
Between 2 and 3 is 1.
Between 3 and 3?
0.
4 and 3?
1.
1. 5 and 3.
Is 2.
2. Okay, now, I don't want you guys to think very hard here, but if you were to look at these 5 numbers now, and if you were to guess, I don't want you to do any calculations, so Anna, it must be your turn. Anna, what would you say the average distance is out of those 5 numbers?
2.
Well, it would be less than 2, right? Because 2 is the maximum distance.
Oh, yeah. So the average would be 1.
Yeah, probably, how about 1.5? Because, you know, there's no distance here, and it's kind of in between those 2 and in between those 2, right?
Yeah.
Okay. All right, so this is our guess. Okay. So we're going to guess that the average distance is about 1.5. We didn't do anything super hard, super mathy. But as we look at that, okay, we're going to say that the average distance from the mean is about 1.5. Okay. That's actually a really good guess. Okay. So here's what I'm going to do. Let me move this over here. We are now going to calculate for the first time the standard deviation, and I'm just going to copy this. Okay. Now on the test, I'm going to have you guys use a small data set, something like this, and you'll have to figure out the standard deviation by hand. Oh, now by the way, let me back up a bit. Okay, now variance, standard deviation. Maybe I should mention this. Standard deviation is the square root of the variance. Okay, you'll notice here I've got population variance and sample variance. If you look at my notes, so population variance we represent as the Greek letter sigma squared. Sample variance we represent as the American letter S squared. And so the so if you take the square root of sigma squared, that's going to give you the standard deviation. Okay, so this is the formula for the variance, and then you just take the square root to do this. Now, one way to think about this, and I know this formula looks a little funny, so this x sub I represents each data point. Okay, and what we're going to do is we're going to subtract the mean. Now, if we're talking about a population, we're going to use the Greek letter mu to represent the mean. And if we're using a sample, we're going to let the American letter X with a bar over it, X bar, represent the mean. Okay, so the mean is going to be the same in either case. N is going to represent your population sample size, and N minus 1 is going to represent your sample size, subtract 1. So you'll notice in both cases here, if we think about these conceptually, and remember this is the variance I'm talking about, but the standard deviations is the square root. Basically what you're going to do is you're going to take the data, you're going to subtract the mean, you're going to square it and divide it by the population. And the same thing here, the data minus the mean squared over the sample size minus 1. Now, you may wonder why this one has an n, this one has an n minus 1. So what I will tell you is go take this graduate level class called Math 50 or 5080 or 5010, I can't remember, any one of those two. There's some mathematical reasons we refer to this being as unbiased, and trust me, you don't want me to do that proof. It's awful. But at any rate, there's a reason why we use n minus 1 rather than n on our sample size, and it has to do with bias. So anyway, just take this formula as it is. It's the data minus the mean squared, you add them up and divide by the population. So we're going to do that right now. Okay. So so x sub I, so once again, I'm going to give you this formula. It'll be part of your, well, actually, you'll print it out. It's right here. And notice this actually has a square root in it, so that's kind of nice instead of squared, but this is the formula that you're going to use, okay? All right, so now in this case, we're going to start worrying about your signs, okay? So we're going to subtract, okay? So here's what I would recommend. Data minus the mean. So if you're doing this on piece of paper on the test, okay, I would hopefully you would label this so that it makes sense to me. Because I promise you on the test, I'm going to give you a small data set like this, and I'm going to ask you to do this. Now, does somebody have a question here? It doesn't look like it. Okay, let me check one more thing. Okay. Okay, so what we're going to do is we're going to take the data and we're going to subtract off the mean. So 1 minus 3. Now, but when I did it over here, I didn't worry about signs, but you should worry about signs. So 1 minus 3 is -2, okay? 2 minus 3 is -1. And what I'm going to do is I'm going to copy this down. 3 minus 3 is 0, 4 minus 3 is 1, 5 minus 3 is 2, okay? So I've got the data minus the mean. Now my order of operations says the next thing I'm going to do is I'm going to square it. Square it, okay? So I'm going to take this -2, I'm going to raise it to the second power. So -2 squared is 4. I'm going to copy that formula down. 1 squared is 1, 0 squared is 0, 1 squared is 1, 4, okay? Now, as I look at my formula here, the next thing I need to do is this Greek letter sigma here. You'll notice in Excel, I actually have the Greek letter sigma there, and it means sum. Anytime you see this Greek letter sigma that looks like an E, that means find the sum, okay? So I'm going to find the sum of these 5 numbers here, 4 plus 1 plus 0 plus 1 plus 4 equals 10, okay? Now, we didn't talk about whether this was a population or a sample, but in either case, okay, I'm either going to divide by n or I will divide by n minus 1, okay? I'm going to divide by n if I'm dealing with a population. I'm going to divide by n minus 1 if I'm going to deal with a sample, okay? Now, I didn't specify at the beginning of the problem whether this was a population or a sample. Typically, we're usually going to be dealing with samples, and so this is the more likely formula you will use. I'm going to do this both ways, just so you can see what the difference is. Remember, we originally guessed it would be about 1.5, and that was a really good guess. So at this point, I'm going to take the 10, and I'm going to divide by the 5. If I assume it's a population, I'm going to divide by 5. And if I assume it's a sample, I'm going to take this and I'm going to divide by n minus 1, which is 4. Okay. So at this point, I've got the population variance, which is 2, and I've got a sample variance, which is 2.5. Now, so we will do a test later on that's called the ANOVA test, which stands for Analysis of Variance. And so sometimes you will use the variance rather than the standard deviation. Typically, we're more concerned about the standard deviation. So remember, the standard deviation is the square root of the variance. So if I take the square root of the population, and I can do the same thing with the square root of the sample, okay? Now remember, when we guessed this before, we did 1.5, okay? So at this point, I'm going to say the square root of 2 is going to be 1.41, okay? Now you'll notice that's very close to our guess there. And if I do the square root of your sample, 2.5, you'll see that that is 1.58. So in both cases, whether I divide by n or n minus 1, it was pretty close to what the guess was. Okay? So that was a pretty good guess. And the reason why I did this was I kind of wanted you to understand kind of the conceptually what the standard deviation is, but these are the more accurate formulas. Okay? So do you guys have any questions on that?
probably later when we start doing it.
Yeah. So here's what I would like to do. We've got about 7 minutes left, okay? What I would like to do is I'm going to come up with some random numbers. And we're going to go between 4 and 16. And I'm going to copy these numbers down. And I'm going to copy them, and I'm going to paste special values. And then I would like you guys to tell me what you need to do. We're going to assume this is a sample, okay? In fact, I'm going to copy this formula here because the sample is the more likely formula that we'll use, okay? This is the sample variance. And what I'd like you guys to do is tell me, if this is my data, tell me how to find the standard deviation. So find the sample standard deviation. Who would like to start and tell me what to do? You've seen it once now, you're all experts.
First, you need to find the mean.
Find the mean, okay? And so the mean is, I'll just find that really quickly. Basically, you're going to add these up in your calculator and do it. So I got a mean of 12.25. Okay? What do we do next?
You can find the average distance from the mean.
Okay, so we'll do the data minus the mean. Okay? So we're going to take 12 minus 12.25. And I'm going to make this formula because we've only got 5 minutes left. I'm going to make this easy. I'm going to copy this down. This was lucky. I usually get a nastier mean than that, so these numbers are sort of nice. Okay, what do I do next?
Square it.
I'm going to square it. So I'm going to take this number raised to the second power, and I'm going to square it. Okay, what do I do next?
Then the sum of all those.
And the sum, and I'm going to cheat and use my sum button there. So I got 92.25.
I mean, then you divide it by n minus 1, which is
11.
Yeah, let's see here. So my n is, I've got a count of 12. So my n is 12. So n equals 12. So in this case, I'm going to divide by
11.
oh, sorry, 10
11. No, 11.
or 11. I meant, yeah.
Yeah, 12 minus 1 is 11. Okay. So this is also, I can call this my variance. And then what's my last step for the standard deviation?
Square it.
Square it.
Square root. Square root of 8.38 works out to be 2.895922. Okay. So let me go back to my notes and say, is there anything that I've missed here? Oh, here we go. Okay, so yeah, so really quickly, you're probably wondering, why do I care what my standard deviation is, right? You're wondering what that was?
Yes.
Okay. Now, let me just show you this really quickly. If I were to draw a bell curve, so assuming that our data are normal, they will look like a bell curve, okay? I'm getting better at drawing my bell curves, okay? If this is your normal distribution, this value here is going to be mu, or your or x bar, okay? This is your population mean. And the idea here is if I go out one standard deviation, okay? Now we're going to assume that my data that I did here for would be 12.25. I think this is too big. 0.25. Okay, so this is my x bar would be 12.25. This would be my mean. Assuming my data are normal, which is a big assumption, But if I go, what is this, about 2.9? So my standard deviation, if I subtract 2.9, I'm gonna make that 3 just to make it easier for the math. So this would be 9.25, and this value would, if I add 3, would be 15.25. Okay. And so what I'm saying is 68% of my data are going to be within 1 standard deviation. So this is 1 or -1 standard deviation. And then over here would be +1 standard deviation. Okay. And then if I go out 2 standard deviations, 1,
Sorry, where are we
2.
getting the percents from? I think I missed them.
So yeah, so this is what we call the 68, 95, 99.7 rule. Okay. And so this is just something that you'll need to remember. If you go out 1 standard deviation, and I rounded my standard deviation to 3 to make this easier to do the math, you'll get 68% of your data within 1 standard deviation. If I go -2 standard deviations, okay, this value here, and I'm going to make this red, if I can find my thing here. This value here, 2 standard deviations. So if I subtract 3 here, that's going to make that 6.25. And this is, if I add 3, this is going to make this 18.25. I would get 95% of my data within 2 standard deviations. And if I go out 3 standard deviations, okay, then that's going to be, so that would be out here if I went subtracted 3, so that would be 3.25 to all the way out here to 21.25. I'm going to have 99%, 99.7% of your data. Okay. Assuming I have a normal distribution. Okay. And so the normal distribution is the most common type of data. I know we're out of time here. I just want to cover one more thing. Well, maybe I'll save Chebyshev. I think there's a question on Chebyshev's inequality. I don't want to rush on that. But Chebyshev's inequality says regardless of the data set, so it doesn't have to be normal, 1 minus 1 over k² observations will lie within k standard deviations. I'm going to explain that tomorrow. And I'm not going to quiz you on Chebyshev. Basically, here's what I want you to take away from this. Can you calculate the population variance or a standard deviation and the sample standard deviation? That's what I want you to take away from chapter 3.2. So, and we'll talk about Chebyshev tomorrow. So I think there's 1 or 2 questions in the homework. You can ignore those on Chebyshev. So, but I won't quiz you on that. I'll give you a quiz on everything else. Okay. So any questions that you guys have for me?
When calculating the standard deviation, is it wise to sort the data first, or does it not really matter?
Doesn't really matter. Sorting your data is necessary to find the median, but you don't need the median to find the standard deviation, so it doesn't matter. Any other questions?
So if we don't have a normal distribution, so like we have something that's skewed or something, how much of this applies, or is it kind of another?
So that's Chebyshev, and I'll talk about that tomorrow. Although I will tell you what, Chebyshev will just show you, I'll show you one time and then you'll probably never see it again. Because most of our stuff we're going to be using a normal distribution in this class. So. Okay, all right, so homework on 3.1 and 3.2 is going to be due tomorrow, and quiz will be tomorrow as well on both of those sections. So I'll see you all tomorrow.
Thank you.
Yep.
Thank you.
Thank you.
Have a good one. We'll see
Thank
you
you.
all later.
Thanks.
Thank you.